Welcome to Electric Perspectives, a podcast that explores the innovations and policies shaping the electric power industry and how America's electric companies are delivering the resilient clean energy we need to strengthen America's energy security and power our daily lives. This show is brought to you by EEI, the Edison Electric Institute, which represents all U.S. investor-owned electric companies. I'm your host, Brian Reel. As America's electric companies work to meet growing electricity demand, mileage from flexible generation is increasingly playing a critical role in supporting a diversified energy mix. On this episode, Eric Holdsworth, who leads the Edison Foundation, is joined by Andrew Phillips, Business Development Manager for Wärtsilä, and Dylan Bearce, Senior Director of Energy Resources Operations for Tucson Electric Power. They explore how electric companies can get more mileage with flexible, reciprocating internal combustion engines, how these engines differ from traditional generation resources, and how they can support grid reliability. Eric, I'll let you take it away.
Andrew and Dylan, welcome to the show. Thanks for being here. Andrew, before we get started, I'm wondering if you can just help us level set and explain exactly what flexible generation is and how it differs from traditional power generation resources.
Sure thing, Eric. Happy to be here. Thanks for having me. So I think we're all pretty well aware of the vast majority of the installed base fleet within the United States. And a lot of that generation has been online for a very long time. And those resources were designed around a completely different type of operating profile. Traditionally, they are larger, more base-loaded facilities. Kind of think the traditional nuclear or thermal assets. But as time has moved on and as the generation mix has shifted to a higher amount of penetration of renewable sources on the grid, the amount of variability on the grid has really increased. And so commensurate with that, we need to be looking at firm, flexible, dispatchable generation to be put online in order to take up the job of helping to balance those variable sources and keep supply and demand where it needs to be in lockstep. So with that, there are a number of different types of technologies that can meet this need, but one such technology is what we at Wärtsilä manufacture and deliver, which is called RICE equipment. RICE stands for reciprocating internal combustion engine. And you can really think about just the engine in your car, but the size of two school buses stacked on top of one another. So this is not your high-speed Caterpillar machines that are used for backup power. This is large, heavy industrial, primary power generation technology. So we've been doing this in the States here for quite some time. We're based out of Helsinki, Finland, but suffice it to say, RICE technology is part of the solution to meet the demands of the grid, both now and moving forward, the need for variable, flexible generation. And it's dispatchable, runs off natural gas, which means you can turn it on and off when needed. And not only is it dispatchable, but it's flexible. So unlike traditional sources that were meant to be parked at base load and run flat out for an extended period of time, this technology is designed and more or less purpose-built around being able to ramp up and down quickly, turn on and off quickly and multiple times without any sort of starts-based penalties or maintenance. And it's really a technology that's well fit for the needs of today. And as part of that, I do want to introduce one concept here very quickly, which is this idea of mileage. So not only do we need flexibility, but we need it to be flexible quickly, right? And so part of this idea of mileage is the concept of being able to ramp up and down in real time to meet the needs that are on the system.
Can you talk more about why Wärtsilä decided to develop this framework and concept of mileage?
Sure. If you look at a given generation source, the ability to move from one set point to the next, ramp up, be there where you need it to be for however long you need it to be there, and then ramp back down, that ramping, that travel up and down is, in essence, the concept of mileage. I think it really comes back to this idea of flexibility and what the markets are needing right now based on the amount of renewables that are on the system. So we are starting to talk more about that just because it really gives us a good opportunity and a good metric to look at how flexible an asset can be over a given period versus other less flexible assets.
Really appreciate the overview and really being able to tie in this concept of the need to keep power steady and the importance of being able to ramp up and ramp down to respond to changes, particularly in intermittent resources like wind and solar. Before we go too much further and before I pull Dylan in to talk about how Tucson Electric and electric companies are kind of applying these in practice, I wanted to take just a moment to talk a little bit about the Edison Foundation, which is the initiative that I run here at EEI, and how flexible generation fits into our work. So the foundation itself is our primary mission is to educate key policymakers and stakeholders on the important role of the power sector in meeting this increased demand that Brian talked about at the beginning, as well as how we're helping to deploy and develop current and next generation technologies to meet that demand. And of course, as part of our focus, we're also looking at identifying strategies and the technologies that member companies can use to help meet this demand and keep it affordable, reliable, resilient, and increasingly clean. And so I think as you just laid out, Andrew, we see already how flexible generation fits into this portfolio and is exactly a great example of the kind of technologies we're focusing on at the foundation. So Dylan, I'd like to bring you in, and I'm wondering if you could just talk on the practical side as a member company. How did Tucson Electric, how are you guys bringing this into your portfolio, the use of flexible generation? And maybe in that, could you talk a little more broadly about how Tucson Electric is looking at meeting its clean energy goals and providing that affordable, clean, resilient energy that everyone is demanding out there?
Yeah, you bet. And Eric, thank you again for the invitation. This is a great topic to talk about. So Tucson Electric Power, I wouldn't consider us unique. We've got a fleet that's aging in some instances and a lot of renewable energy penetration on our system. And the moment you have non-dispatchable intermittent resources, you've got to balance that out with the changing demands of the different customer bases, whether that be residential, commercial, or industrial. And you want to do that the most economical way. And a lot of what Andrew spoke to is the same problem statement we were trying to solve, is how do you take 1950s vintage technology and relook at it to say, does it make sense to retrofit? What sort of transmission constraints do you have? And what's your dispatch model look like? And so what Tucson Electric Power did is we did a technology assessment and said, what is the problem we're trying to solve? And so we went through a very robust process to figure out from a feasibility standpoint, what technology are we looking at? What does our current and future forecast look like? And then what are the different system upsets that we have to account for? And so we spent a lot of time really diving into that. And then it broke down to the economics and the footprint and a lot of the other things that go into siting new generation. And what we found is that we needed to retire some of our older assets. And so if you can picture 1950s vintage resources, which for us was two small 80 megawatt conventional steam turbine gensets, with their non-emissions controlled in the back end, it just made sense to put more flat heat rate technology in place, which the RICE do. And so you can bring them up, put them at a minimum load, ramp them up and down, and you don't really take heat rate penalties. And so that fuel efficiency makes them economical on top of being fast on and able to move around. Then you take into consideration all of the emissions controls that you can bolt on and that's proven on the back end. Well, now you're driving down your nitrous oxides and your carbon monoxide, which helps you meet your carbon goals. So now you're meeting the customer's needs. You're able to cycle on and off and not burn fuel at all, have non-spinning reserve as an opportunity to continue to meet that demands. And then when you need them, they're air to start. And so what we ended up doing was really getting a lot of water benefits out of the closed cooling system. So it's not all just carbon goals. There's a lot of other important things for us. We're in a desert, and so water is a pretty finite resource. And I know we're not unique in that way, but anytime you can actually make air quality improve and even increase the capacity factor, that's a win. Then when you have all of the heat rate gains, that's a win. And the variable O&M's pretty flat. And so when you think about the customer affordability, you think about your emission rates, the decrease in water, and the footprint that we were able to accommodate, we were able to pretty quickly come to, for our circumstances, given our penetration, the RICE engines were really the best technology for the problem we were trying to solve.
Yeah, sounds like a no-brainer from the way you described it. And what a great solution, right? You're able to keep the same level of power, decrease emissions, improve air quality, a number of great benefits. And this is the kind of thinking that we're trying to highlight at the foundation. So appreciate you sharing that. And, Dylan, maybe if I can stick with you, but then Andrew, I want to bring you in on this. So one of the things that we love to talk about is how member companies and their technology providers met each other, how this project came to be. And Dylan, I'm wondering, maybe it's a little twist on that. If you could talk a little bit about regulatory approval process and sort of what types of studies, what did you all have to go through at the company level to get this approved? And then Andrew, I'd love to come back to you and maybe get a little bit on how you found Tucson Electric and how that partnership came together. But Dylan, maybe you can talk a little about the regulatory process first.
So this installation that we're talking about happened in the state of Arizona, but in the contiguous US, you've got some regulatory body. So your line siting, the megawatt capacities, those processes and governance are going to be slightly different. For us, we have state approvals, we've got city approvals, development plan, your typical large industrial application sort of permitting process. So you've got all of your normal regulatory constructs, but there's a lot of stakeholder involvement. And so it's interesting. This was installed, somewhat designed in 2017, but really went in service in 2019 and 2020. We started to see a significant increase in customer input. People wanted to be involved, depending on if you're an independent or a regulated utility. Obviously, you have governing boards and different financial constructs to work within. We're actually wedged in between two state parks. And so your regulatory sign-offs can be pretty extensive. And so when you're looking at replacing technology rather than just adding capacity, I would say the permitting was different. And so ours was a little bit of a give and take, as we opted to retire some assets and replace them with more efficient and gain a little bit of capacity along the way. So I would say, generically speaking, we follow the same process as others, but it's not all required. It's best practice and really a minimum expectation anymore. So that stakeholder involvement was a bit of an aha moment of, wow, this is really valuable. We're getting a lot of good feedback from the communities and the different interveners that like to get involved in these activities. And that seemed to really make things more smooth, being transparent, hosting a lot of public events and things. If I may just give one example in that process, is we're in a city limit next to an interstate at this one site. And the radiator fans, they can be somewhat noisy. And so there was a concern of whether or not putting them on the side of the fence line was a good idea. And so rather than do modeling and depend on the accuracy of it, we just flipped the whole project 180 and put the fans on the other side and put the engine halls in between, and it wasn't a concern. So those are some of the stakeholder input items. That was it required? No. Did it help? I think so. And it just shows that we're willing to pivot and be creative. And Wärtsilä was very flexible in that way as well. So a lot of good outcomes with some of the processes that we followed.
Yeah, appreciate you sharing that. That's a common theme I think we hear across the industry, the community outreach and engagement and how helpful that can be. Just thinking a bit beyond Tucson Electric, and I think you just mentioned this talking about other customers. Can you talk a little bit? I think you've hit on this a little bit in your work with Tucson, but maybe more broadly, how flexible generation can help companies that have set carbon-free and low carbon goals to achieve those on their systems.
Sure. So I think we're all pretty well aware of kind of where things have been heading from a renewable penetration standpoint. But we in Wärtsilä have actually done a lot of our own modeling to look at what the impacts of a higher percentage of renewables on the grid are. And based on our analysis, we really see that in order to get to those much higher levels of penetration, you need a lot more flexibility on the system than what you're used to seeing, right? And so I won't get into all of the, the varying targets that we see throughout the United States. Obviously, it's dependent on jurisdiction here, but to speak to it more broadly, if you want to get to those higher levels of renewable penetration, you really need to have a large amount of highly flexible, dispatchable, firm capacity on the system. And so we think that we are very well positioned to be able to play a part. I think that folks should not overlook the value of smaller discrete shafts, of highly flexible assets, in order to enable them to make that transition from, say, a 20% renewable portfolio standard to a 40 to a 60 to an 80. And really, once you get up into those higher levels, that's where the value of the flexibility becomes even more pronounced.
That's one thing we talk a lot about at the foundation. You really need all the tools in the toolkit, right? And not everybody needs every tool, and different people will need different tools, but you need them all. And obviously, this is another key technology that people can utilize to help meet those goals and meet load and keep things reliable and affordable. And I think those are critical pieces. So, Dylan, from your perspective, I'm wondering if you can talk to us about how this mileage concept that Andrew's been talking about applies to Tucson Electric's fleet of generation resources. Can you talk about how it informed your decisions about dispatch strategies or resource adequacy?
Sure. So mileage is an interesting one. We happen to be in a real-time market. The 5-minute market's a pretty big deal and pretty volatile. And so being able to ramp is that fast, flexible branding that we've been throwing out there for the ability to get a resource online at a minimum load and not take a bunch of heat rate penalties, which is fuel per kW put out. That's massive. So if you can get the resources down at the bottom to sit there when you want them and then run them up and down with a pretty flat amount of fuel, you got a lot of predictability. So if you're not creating your own volatility, trying to calculate your variable O&M, your fuel costs, the impact to the customer, having a flat line makes that mileage pretty efficient. So if you compare it to an automobile, a traditional, fuel-driven car, you kind of want that highway. You're looking for that 30 to 45, miles per gallon. And when you think about if it didn't matter if you were city driving, that's a big deal. And to be able to jump on and off and know that you can go X amount of miles on a tank of fuel, that's what we're looking for. And so when you think about compensating for renewables, compensating for varying customer demands, if you've got industrial customers or commercial customers that have arc furnaces or something that really has these surges, you've got to chase that. And we always joke that we're the masters at real-time manufacturing. That's what mileage is. It's chasing at the speed of light, whatever the demands are or are not. And I think the value that we've gotten has proven that we can get these online very quickly and we can chase that and we can keep up. And you don't ever want to be too far in front or too far behind. So you're the pace setter, and having a pretty flat heat rate really allows us to be more predictable. It's simpler math and it allows us to quantify it easier. And these machines have been very successful at doing that.
So, Andrew, just to spin back to you on this, and I think we've touched on this a little bit about in terms of how member companies can help meet their carbon goals in the role of flexible generation. Of course, we're also talking a lot about this need to meet increased demand, and I think you yourself indicated this is a tool in the toolbox. But wondering if you might be able to elaborate a little bit more on how flexible generation can help members meet this growing demand while keeping energy affordable and reliable.
If I just kind of think about it from a high level, if you've got a large inflexible asset, as Dylan was saying, you're not able to chase the dramatic drop in solar that might occur here in Arizona when you've got a summer thunderstorm, or really the wind stops blowing in the SPP market footprint that's heavily penetrated with wind. I mean, the list goes on. So if you've got a large, call it gigawatt facility that doesn't like to ramp, doesn't like to start and stop, just wants to sit there at base load, kind of fat, dumb, and happy, so to speak, then you've got the wrong asset. And so as those renewable resources come online in increasing quantity, you've got to ramp up the amount of that flexible generation that you have on the system. And that allows you to get to those higher degrees of renewable penetration, right? So if you've got a carbon goal that you're looking at and you're saying, hey, I've got to reduce this by increasing the amount of renewables on my system, then you really need to look at how you're positioning other assets, newer assets, or potential changes to your existing fleet to really be able to enable that. On the one thing I do want to mention on sort of the carbon footprint standpoint, I know there's been a lot of discussion around hydrogen lately. I do just want to mention, so these RICE engines are hydrogen capable up to about 25% hydrogen by volume. So I think we could have probably a whole hour conversation on hydrogen itself. So I won't go down that rabbit hole right now. But I do just want to mention that for folks that are interested, that is a capability that we have. We've done some real world tests with some other customers of ours here in the United States. And so really from a carbon standpoint, I think being able to look at future fuels, hydrogen is the predominant one now. We're also looking at ammonia. Kind of thinking about that larger power to X transition, but also the flexibility that enables you to have those increasing amounts of renewables on the system. That those things all kind of, in my mind, work together.
I appreciate that kind of looking to the future there with the tip to hydrogen. And yeah, no, right, a lot of interest in down the road what role that might play. So appreciate you sharing that. I wanted to maybe flip back. We talked a little bit about the approval process that you all went through to get this onto the system, and just wondering on market structures, market regulations, and whether those are supportive of this kind of, I think, Andrew, you mentioned this mileage-based ramping up, ramping down concept. So maybe Dylan, start with you and what you see in the Tucson area, but then Andrew would love to hear more broadly what you all might be seeing across the country in terms of, we find a lot of these technologies, sometimes it takes a while to penetrate. Just curious about whether you're finding the current structure is supportive of bringing these kind of resources on relatively quickly. So Dylan, we'll start with you and then we'll pivot back to Andrew.
Sure. Yeah, I appreciate that. They're all a little different. In the West, I'll just say uniquely to us, there's not a lot of gain from a capacity market, but the intermittency's got a lot of value. And there's a lot of renewables on the West Coast. And so when you think about the intermittency of that, whether or not the snow melt is the way you expected it to be, and hydro's performing a little bit different, the excess solar, maybe there's some transmission constraints, a lot of wildfires. There's a lot of contributing factors to it. And so when you think about how these play into the market, and I'll just isolate it to the West, they play in very nicely. Part of the way you bid into these markets is you got to price your resources, and we call it the economic dispatch. I mean, the whole thing's affordability. We can't justify spending more money and dispatching more costly resources. And so you look at the demand, you look at how you're going to meet the demand, and you do it by reliability and cost. And so the way that these have been modeled have been proven to be dispatched pretty heavily, and they're meeting the needs. And so that's only because they actually do what the system needs at the right price. And it depends, right? It's intermittent. Sometimes you just need that base load resource, and maybe an hours-based machine is the right move or not the right move. And so organizations got to dissect that down to identify what's your real model, what sort of contingencies are you going to carry. A lot of entities are now looking at increasing it beyond the regulatory requirement, given the intermittency and the volatility of some market structures. And so when you think about the import-export within California ISO, there's a lot of challenges in that state, and that can really interfere with your ability to market across state boundaries. And I would say in the West, it's proven to be valuable to our customer. It's allowed us to restructure how we do things to be the most affordable and lean on some of these, less costly resources when it makes sense. But we also know the pricing of our resources. And I'll just speak to the rice. They've been very effective at keeping costs down. They're hours based, and so we can predict maintenance. So we can really control the maintenance and the planned outage periods, which is valuable because you don't want to get caught in the middle of the summer having to take your resources down when power demand is at its height. So I'd say that's high level, some of the processes that lead into it, and it's pretty commonly done throughout the states.
Appreciate that, and appreciate you pulling in the California market as well, and some of the variability there and how that impacts the West. Andrew, what about you? What are you seeing more broadly in terms of ability of this technology to penetrate and be accepted by markets? Are the regulatory structures working for you all? Are you seeing any hiccups?
Yeah, good question. So from our standpoint, and I will just say this, I'm actually based here in Arizona as well. So looking at, keep that in mind. But I do a little bit of work in kind of the SPP market footprint, and have had a little bit of touch time with ERCOT as well. And we've done some modeling to support some customers with their technology selection. And what we've found is that the real benefit of the RICE equipment is in the real-time energy market, right? So Dylan talked a little bit about capacity, right? That's a part of the play. And obviously everything depends on what market structure you're currently trying to serve in. But if we just look at sort of the SPP and ERCOT examples there, they've got some strong real-time energy pricing that is very variable, depending on what's going on, again, with the wind and the solar on the system. And so based on our modeling, we've seen that the lion's share of the value of the RICE technology over some other types of turbine technology really comes from those real-time energy markets. And so back to that mileage concept, the fact that, as Dylan said, you can start these engines in sort of 2 to 5 minutes, depending on the type of equipment, the fact that you can ramp to full load in essentially 1 minute, and then stay there however long you need to, ramp back down, turn it off entirely if you need to get out of the way of some negative pricing or low pricing. That mileage piece, like I was talking about before, that is really the enabler in being able to capture increasing amounts of real-time energy value and revenue. And so once you look at that, it really kind of, I think historically people looked at rice technology and thought that it was a little bit more capital intensive versus, building a larger scale combined cycle facility or something like that. But that CapEx premium really gets made up very quickly with the increased capturing of real-time energy pricing spikes, I should say. So I think from where I sit, the regulatory climate looks pretty favorable for rice, but I know that different market structures are looking at making changes. SPP and MISO are talking about new accredited capacity rules. We've been looking at that quite heavily. And we feel that our technology is pretty favorably positioned to take advantage of the new accreditation rules that are changing there. So I think that the regulators, I think that the markets are starting to pick up on the value of this equipment and making the changes that are necessary to make sure that it's valued appropriately.
No, thank you. Appreciate you sharing that. And yeah, no, right. It's really interesting to hear about the like that ability to find the value in in different parts of the energy market and how flexible generation can help companies take advantage of that. So thank you so much for sharing that. I think that really helps folks kind of understand right where this fits in and how it can play a key role in your planning. So thank you for sharing that, Dylan. I know we're starting to run short on time, but I did want to take an opportunity to hear from both of you a little bit about the lessons learned question. So Dylan, let's start with you and then we'll pivot to Andrew.
Yeah, some are lessons learned and some are lessons exercised. What I would say is that in many ways, it has really tightened up the communications internally. We're vertically integrated, so we've got our own balancing authority, we've got our own marketing group, et cetera. They're key. And so if you can understand how you want to use this equipment, how to price the equipment, how to bid the equipment, how to show the return on that investment, that is really important. It is even more stringent now, especially when you enter markets. Bilateral trading, independent power producer, maybe not quite as complicated, but it depends. And so I would say that engagement to identify that early is key. The other part, rice were new for us as an organization. And we have a lot of folks that are good at diesel mechanics, and a lot of it's pretty typical. But what I would say that when you think about, are your people qualified and capable? Are you ready? So if you're going to make this significant capital investment, it might be good to involve, like we did, we had an engineer that stuck around for a year, help train our folks, help troubleshoot, engage, identify spare parts, go through your inventory management, and true up how you're going to be dispatching it. But then there's this other side that says, okay, how do you quantify the actual performance? And so if you're getting that mileage that Andrew was talking about and seeing the ramp up and down and seeing the cycles happen, what does that maintenance interval need to look like? And I think doing that early can tell you, are you in a good spot? Is your commodity, do you have the right number of storage gallons of oil or ammonia injection, whatever your system includes? Those are just some of the real key attributes. The personnel and recruitment was a big one for us. I feel like the skills of today may or may not be the skills of tomorrow. And we've been chasing aptitude and attitude more and more to make sure that we got folks that can adapt because technology is changing. We go to hydrogen, it's going to burn different. It's going to have a different signature. And we want to make sure that our stuff is ready. Do we have people that can do natural gas and convert right over and have an open mind? So I think all of those are critical pieces to pay close attention to early on, and you'll reap a lot of rewards from it. I feel like that got us ahead of the curve, and it wasn't quite as disruptive as it potentially could have been.
I appreciate you sharing that. Andrew, how about yourself from Wärtsilä's perspective? What were some of the lessons you all have taken away, or maybe, lessons both learned and lessons taken from this partnership?
No, certainly. And I do want to, give some props here to Dylan. I've worked with him for quite some time on this exact facility, and he and the Tucson Electric folks have been a pleasure to work with. And so I think it's really a good story that we've got here and how organizations have worked together to design, build, and operate this facility. I think the big takeaways in my mind are it starts with education, right? So I think for most of the customers that we have here in the United States, obviously we're a company based out of Helsinki, Finland, right? So we're a foreign company, and so getting them used to working with some folks that are Finnish and have a little bit of a different culture and way of communicating, that takes a little bit of education, but also educating our customers on the product, right? As I mentioned before, when you say rice, I think most people think smaller high-speed Cat diesel machines. This is not the same type of technology. And so educating them on our technology portfolio and what it can do for them, I think, was a big piece. We mentioned the partnership, and I do want to say that I'm very grateful to be working for a company that really puts its money where its mouth is when it comes to partnering with customers, right? Not just a simple transaction and then we hit the road and you'll see the taillights, right? This is a company that really wants to stand by their product, stand by their technology, and stand by their customers. And so I do appreciate that. And then finally, I think that one of the things that we have done a really good job of building up the capability recently is helping our customers model how this technology can support their systems. So we've got the ability to do some modeling internally to look at how this technology can help balance some of the rest of their generation fleet, how it can help them maximize the revenue potential, again, depending on the particular customer and their business model. But part of that is helping them understand how to value this mileage piece and this ability of the equipment to ramp up and down very quickly to balance the fleet, to maximize revenue potential, and et cetera.
I appreciate you sharing that. And I really would like to thank both of you for taking some time today to talk to us about flexible generation and the role this technology can play. It's another really fascinating tool we've been exploring recently in other podcasts, things like virtual power plants and flexible load and being able to curtail buildings. And here's another example of a resource that people can deploy that's currently available. But this is a great example of these types of technologies where members are able to find them, deploy them, keep affordability, keep electricity affordable, but also meet the growing demand and ensure reliability. So I really appreciate both of you taking time with us to share this journey that you're on and what you've learned and the important role of flexible generation. And so, Andrew, if people want to learn more about flexible generation technologies and the mileage concept that you've been talking about, where can they find that information?
Sure. So the two ways that I would recommend, the first is going to be just to visit our website, wärtsilä.com, WARTSILA.com. I know it's a Finnish word, so figured I'd spell it out loud. But if you go to wärtsilä.com, you can find some more information. We've got links to our product portfolio. We've got links to some white papers that we've done on things like mileage, things like flexibility, renewable penetration, et cetera. And then for those that are listening here that want to reach out to me directly, feel free. I am on LinkedIn, so drop me a message. And if I'm not the right person to support you based on the region, then I can certainly get you in touch with who can.
Well, thanks, Andrew. Dylan, thank you also for joining us. Appreciate you both sharing this great story and telling us a lot more about flexible generation. And I think with that, we're going to wrap up today's podcast. So thank you all, and we'll be back with more on the next issue.
Thank you very much. It was a pleasure.
Thank you.
Thanks.
That's our show for today. Thank you for listening, and be sure to subscribe on Apple Podcasts, Spotify, Podbean, or wherever you get your podcasts. To learn more about EI's members and the electric power industry, visit our website at electricperspectives.com.